Hello and welcome to the second season of Digital Science for You. Cyber School Technology Solutions is an organization that's revolutionizing education. They've got a software, digital science, and virtual lab. The software has 6,326 videos and animation. It covers around 120 topics of the curriculum and has 157 experiments in their virtual lab component. All this comes with a package of quizzes and tests, if you like. And as a student, I advise you to get yourself this copy. To get it, you can head over to Uma Showgrounds Lugogo and look for Cyber School Technology Solutions, or head over to social media and look for CSTSUG. So sit back as a student and let's do some learning. Now, if you're a Senior 3 student, now is the time for you to pull out a laptop and open the software Digital Science and Virtual Lab. Because guess what? A chemistry teacher, and that teacher Naboth, is going to be using that software to help you understand a topic called organic chemistry, and that's alkenes. I'll be right back after this.
Hello students, I'm your teacher Naboth. Today we're going to have a Senior 3 chemistry lesson, and our topic is organic chemistry. We are going to use digital science and virtual lab. So parents and students, switch on your computers and laptops and we start our lesson. Those who don't have the software, you can come to Uma Showgrounds and reach out to Cyber School Technology Solutions. And our subtopic is ethene. So we start our lesson, we go to chemistry, and the topic organic chemistry, and then we go to alkenes, and we show. So alkenes, we shall go to the notes, and alkenes are a group of hydrocarbons which have got at least one carbon-carbon double bond, and they are represented by a general formula CnH2n, where N is equal or greater than 2. And alkenes are a family of hydrocarbons which we called homologous series, which have got that general formula as I've shown, and the simplest of these is ethene. Let's look at the structure of ethene. So this is the structure of ethene, where the white represents hydrogen atoms and the blue represents carbon atoms. We can see the carbon atoms are joined by two double bonds. We can show it in different ways. We can look at the different axes. We turn. This is the structure of ethene. Can we use the y-axis? Y-axis to look at the structure of ethene. We rotate it. That is the structure of ethene. It contains two carbon atoms and 4 hydrogen atoms. Let's go to the structure of other alkenes. We are looking at the structure of the alkenes, and ethene, which has got 2 carbon atoms, has got a structure which is shown there, and it has also a molecular formula C2H4. Remember, I said alkenes have got a general formula CnH2n. So in this case, for ethene, N is equal to 2, and therefore we have C2, and then 2 times 2, which is 4. And that's why we get the structure of ethene, or the molecular formula of ethene. For propene, N is equal to 3, and therefore our formula becomes C3H 2 times 3 H6. This is where we get them. And our syllabus emphasizes majorly the first two alkenes, and that's what we shall look at. Let's go to the other structure, the structures of these compounds in detail. Ethene has molecular formula C2H4, as we have seen, and it's a gas at room temperature. I want you to get it. As we go to the properties, you should be able to know the properties of ethene. In the structure, we can see we have two double bonds between the carbon atoms, represented by the black. And then we also have the hydrogen atoms, which are bonded to each of the carbon atoms. Remember, carbon has got a valency of 4. It cannot form more than 4 bonds. That's why we must have only 4 bonds on each of those carbon atoms. Let's go to propene. Let's go to propene. Propene has got a molecular formula C3H6, and it's also a gas at room temperature. Most importantly, the structure of propene. We have got 2 carbon atoms joined by a double bond. Then the first 2 carbon atoms are joined by single bonds. Why don't we have 2 double bonds on between each of the carbon atoms? To maintain the valency of carbon, you cannot have another double bond. So you have only 1 double bond between the carbon atoms. So we shall look at ethene, which is the most important alkene, and we'll look at its properties, how it is prepared in the next slide. Now let's look at the properties of ethene. Chemical properties of ethene. Now, before we look at chemical properties of ethene, let's look at how it is prepared in the laboratory. 1, ethene is prepared in the laboratory in 2 ways. 1, by dehydrating ethanol. We can use sulfuric acid, or we can use aluminum oxide. Now, when you are using concentrated sulfuric acid, this is the setup. We need concentrated sulfuric acid. We also need ethanol, which is put in the round bottom flask. Conditions: there should be heating. And in this preparation, the heating is specific. The temperature must be between 170 to 180 degrees Celsius. And the acid should be concentrated and also in excess. So, I am going to play the animation. I'll pause it there. So, when the gas is produced, it is bubbled through sodium hydroxide solution. You can use 1 bottle when it is concentrated, but you can use 2 bottles if you are using a 2 molar solution. So, the gas is bubbled through sodium hydroxide solution in order to remove some traces of sulfuric acid or even some sulfur dioxide that can be formed in the process. Let's continue playing. The gas is bubbled through sodium hydroxide solution, and then later it is collected over water because it is slightly soluble in water. Let's check on the notes. Ethene, as I've said, is prepared by heating a mixture of ethanol and concentrated sulfuric acid. The gas is passed through sodium hydroxide solution to remove traces of sulfuric acid, and then the gas is collected by downward displacement of water because it is slightly soluble in water. Now, let's go back to the animation at the beginning. I'm taking it at the beginning. This setup brings out some of the physical properties of ethene. When it is produced, if I play it again, what is the color? It is a colorless gas. What does this say about solubility in water? Because it is able to pass through the water, it means it is insoluble or slightly soluble in water. And when we finish this, now we can be able to look at the properties. But for emphasis, let's look at the equation. The equation, ethanol, which is a liquid, heated at 170 degrees Celsius, under concentrated sulfuric acid, is dehydrated and we get ethene, which is a gas. The water, which is produced, is not a product, but it is taken up by sulfuric acid, because sulfuric acid is a strong dehydrating agent. Having looked at preparation of ethene from ethanol and concentrated sulfuric acid, we shall look at chemical properties of ethanol. But before that, let's go for commercial break, and I want you to tune in and turn on the sound and observe what is taking place and hear what is taking place within this setup.
Ethanol reacts with concentrated sulfuric acid to form ethene and water. When vapors of ethyl alcohol are passed over aluminium oxide, ethene and water are formed.
Now let's head into a short break. Don't forget to head over to Facebook, Twitter, or Instagram and look for CSTSUG. You can be able to inbox us and we shall reply instantly. Right now, we head into a short break. When we get back, organic chemistry by teacher Naboth using digital science and virtual lab.